Right. So before we begin, I guess one quick check: audio, video, and everything okay? Are you guys able to see the screen and the PPT? Whatever I'm writing on it. Hope everything is visible, audible, and clear. Okay, perfect. So, quick introduction about me before we begin. My name is Sangeeta, and I'll be doing your sessions on quant as well as logical reasoning, some modules at least. And I've been training students for various various competitive exams, that is, for the last 8-9 years almost. So I've been training for CAT, GRE, and other entrance exams as well, right? So this batch, we are, I think, recently started off with this batch. So how many of you, let's have a quick understanding of the group here while I have more people joining in. For those who are here, let's see and understand how many of you here are working, still in college. Let's see quickly. Anyone who is in the third, fourth year, or anyone who started working. And most importantly, when do you guys, all of you planning to take CAT this year, 21? Fine. Okay, you're doing BBA. Okay. Shubhankar, somehow your name seems very familiar to me. Have you been a student with us earlier also? I could be wrong, but yeah. Yeah, exactly. I could identify from your name. You were in Gyanville. Yes. Okay, good, good. So, where are you doing your BBA right now? And Vijay, you are in your final year. Okay. NMIMS. Good, good. Okay, what about you, Vijay? Where are you pursuing? You're doing BBA, I understand, or engineering, is it? What about the others? I need responses from all of you, like quick, quick. Okay, Farhan, final year BCom. Okay, you're doing your BCom from Adarsh College. Okay, okay. Few more in the class, silent so far. I don't want any of you guys to be silent. I understand it's online, so not silent meaning replying on the chat, right? So, and most of you are in your final year, I understand. Okay, Laukya, you're also final year. This is degree college. Okay, and all of you are planning to take CAT this year, 21, or is anyone started off a little early? 21 CAT is what I believe. 21. Okay, okay, good, good, good. Kavyashree, okay. Right, and I understand that you guys have already started off some. I think in the this round, a few sessions of vocabulary have already been done as part of your verbal ability section. So broadly speaking, I'm sure all of you are aware about the sections and the patterns. And although I wouldn't say syllabus, because CAT as such never really specifies a syllabus per se, but whatever it is, when we are talking about, let's say, quantitative aptitude in particular, we always say it is your 10th level maths, right? It's the 10th level maths, but yes, the level of questions could be obviously higher than that. But if you take into account the topics as part of the syllabus, that is what we expect usually. Now, broadly speaking, I'll be doing your quantitative ability, some modules of that, as well as your DILR section, right? LID, LRDI or DILR, whichever way you want to call it, right? So let me ask you this, and obviously verbal ability is being done by another faculty, verbal ability and reading comprehension, or your VARC section, right? So since we are starting off with quant today, let me ask you a question. On a scale of 1 to 10, where do you guys rate yourselves for quant? How okay, how comfortable you are. I'm not really talking about, maybe CAT level questions and all. In general, how comfortable, how good, how fast do you think you are in quant? Overall, rough idea, according to you, your own estimation on a scale of 1 to 10, where do you guys rate yourselves? Okay, Shubhankar at a 5, decent enough. What about the others? 5. Everybody taking the safe side, 5. Come on, come on. If someone is confident, Farhan, okay, today's your first class. I understand. See, a lot of you, it will be the first class. And even if you have joined a little earlier, maybe you did a few classes of verbal ability earlier. What I mean is, in general, I mean, throughout your school and throughout your college days, how good, how comfortable have you guys been with quant? That was my question. Okay, Harika, good, 6. Vijay, also 6. Okay. Lokya, again, we are at a 5. Okay. Good, fine. Now, broadly speaking, before we actually start off with today's session, I'd like to give you an idea about the different modules that you will be covering. Modules as in different topics, right? Topics again are smaller in smaller categorization. Module as in, I mean, the bigger categorization as in. Broadly speaking, if you see your quantitative aptitude in CAT or any MBA entrance exam for that matter, when we are preparing not only for CAT but for other exams as well, right? So broadly speaking, any exam that you talk of, the quant section will be broadly divided into your arithmetic, right? And then you'll have algebra, pretty common topics. Then you'll have your geometry, right? And modern maths. Right. Again, what I've given here is a very broad classification. Now, within arithmetic itself, there are so many different things to be learned, and we'll be doing each of them as a separate module, right? So, arithmetic, algebra, geometry, and modern maths, broadly, these are the areas. Arithmetic further can also be divided into your basic arithmetics, your percentages, averages, ratios, simple interest, compound interest, profit, loss, and those kinds of things. Then, you'll have your time, speed, distance, and time and work kind of concepts that will also come under arithmetic. And number systems, although yes, sometimes it is treated as a separate module, separate topic, but yes, can be considered under arithmetic as well. Number systems. Understand your number systems from CAT or any other MBA exam point of view. Number system is a very, very important topic. And you'll see as the classes progress, we'll be doing each of them as a separate module. Like we'll be having 3 sessions on number system separately, 3 sessions on time, speed, distance, 3 on basic arithmetic. Then you'll have algebra, geometry, modern maths, and all of that coming in, right? So although yes, we cannot really pick and choose one topic over the other, but number systems definitely is something that is one very crucial topic throughout your quantitative ability section in CAT or other exams as well, right? So this is how, and mostly you will see the classes will also be planned in a way that you finish one module continuously. Like let's say today we are doing an introduction, sort of a speed maths kind of a session, but next let's say we start off with, let's say, arithmetic. We'll do 2-3 continuous sessions of arithmetic. We'll close it before we move on to another module. And in between you'll have modules of English coming in, you'll have modules of logical reasoning coming in, and so on, right? Another thing is, like, I mean, so far, I mean, since we are in the beginning of the program right now, for the last week and this week, you see that we are having alternate day sessions. But from the coming week onwards, we'll be having sessions daily. So you need not worry about that part as well, right? Since people are still joining in and all, we've decided to do the first 2 weeks would be 3 sessions a week. But yeah, from the next week onwards, we'll start off with daily classes for you guys, right? So with that in mind, let us go ahead and understand what we have for today. Now, I hope all of you have access to the books, all your worksheets. Basically, all the exercises that we'll be solving in your class are available in your books. So you can refer to that, or I'll be doing the questions. In any case, the questions are going to be on display. But all these worksheets you can always refer to in your books as well, right? Now, when we talk of speed calculations or calculation techniques, now I'm sure most of you are aware, although I don't want to, put that out upfront, but yes, there are some exams that do allow an online calculator. But you might ask, then, if an online calculator is available, why do I have to, learn so much about speed calculation after all? But understand, having a good calculation speed is something that is very, very necessary, right? Because your online calculator also, you cannot really, I wouldn't suggest that you rely on it too much, right? It is definitely not suggested. Go ahead and yes, it is available to you, so you can always use it. But remember, it's not a calculator which you can operate with your keyboard and all. It is usually something which is available with a mouse. You can only click with the mouse. So understand, doing long calculations, clicking every digit, every number, every operation is also going to take time, right? So, and again, there could be exams which do not allow calculators as well. So keeping aside the fact that calculators may or may not be available, we still need to focus a lot on improving our overall calculation speed, because you'll understand, the faster you are able to calculate, obviously it is going to make your questions and the time it is going to save a lot. So better focus on that. Don't start questioning kya re calculator hai, I can always rely on that. Do not do that, right? So today's session, I want you all to focus and try to understand and pick up on the various methods that we'll be discussing. And again, one word of caution: this is not something that acha, you did one class and the very next day you will get you'll be perfect in it. No, it doesn't work like that, right? So it will take a lot of practice from your side. So keep practicing a lot. Even when we are doing the class today, if you have doubts, ensure you keep putting it up on the chat screen here and keep practicing, because the methods might look simple, sometimes it might look complicated, but the more you practice, the easier it is going to get, right? So broadly, we are going to be discussing a method called base method. In case some of you are already aware of it, great. It could be a quick revision for you. Others, those who are not aware of it, you can go ahead and we'll check it out. We'll have base method, and within the base method, we have a lot of variations under it, right? And we'll also look at something called a crisscross method. Now, broadly, these will be the two, and in between, I'll keep giving you some other tips and shortcuts also as and when necessary, right? Now, any idea anyone here knows or has done earlier or is aware of this method called the base method? Anyone? Base method of calculation is, does anybody have an idea? Again, like I said, okay, Harika, you already have an idea. Right. This is pretty much the worksheet. I have it as a single worksheet. This is the same thing that is available in your books, like I said. And it is also, I've put it up on the PPT for us to, conveniently solve the questions. Right. Now, first things first about base method. Again, like I said, we'll be doing different methods. So at the end of the class, you should be able to understand, given a question, which method works out best in that case, you should be able to decide that. Now, base method, understand, is a very, very good, is a very efficient method, but it has some constraints. Within those constraints, if you apply the method, it will work wonders, right? For some particular numbers, you'll see that the base method works really, really fine and easy. Now, one rule or guide, one general rule you have to remember for base method, the restriction I was talking about is that the numbers should be close, right? As in, the number should be close to a common base, right? Some common base is there, the two numbers should be close to that. In case you find those kinds of numbers, you can always go ahead and apply this, right? Now, when I say close to a common base, this base I'm referring to a power of 10. Okay, so first we look at the basic, right? The most common, let's say 10 power n. What I say, for example, if I'm trying to solve, let's say 102 into 103, right? Something very similar to what you have in your worksheet. We'll come back to the worksheet also. 107 into 111, or the example that I've just taken here, 102 into 103. They're both close to a common base. What is the base that I'm talking about here? 10 power n or 10 power 2 in this particular case, right? So base method, remember, for example, if I have a number like maybe 102 into 405, I might not use the base method, right? That is not going to be helpful. So understand where all you can use this method, and you'll see how quickly it works actually, right? Now, so yes, as I was saying, so 10 power n or 10 power 2 is my common base here, and I can always express these numbers as what? I can write one of the numbers as 10 square plus 2 and the other number as 10 square plus 3. Clear so far? So the general form I'm writing down 10 power n plus a, 10 power n plus b, right? Now your answer, understand, will have 3 blocks to it, right? The answer will come out of 3 blocks, because simple, when you do a 2 cross 2 multiplication, a 3 blocks is what you get. 3 blocks as in 3 places. I do not mean 3 digits only in this case, right? I'm saying 3 blocks. We'll understand the logic and the concept about these blocks also as we solve. Now, one very simple thing you have to remember: this place is 1, this place is a plus b, this place is ab, and that's it, right? When I say and that's it, there are definitely a lot of variations to it at every step or at different kinds of problems. But first, let's understand and get a hold on the first and the most common type, right? This is your general form. This is something that I want all of you to remember. Two numbers close to a common power or common base of 10. This is how I can write it. And this will be my final answer. Again, when I say final answer, I need to do a little bit tweaking depending on the number, right? Now, let us see, let us check out here. What will I get here? I'll parallelly also try to explain a 12 into 13 so that you understand how the 102 into 103 will be different from a 12 into 13, right? Now, what do I get here? I'll have a 1 here, and I want all of you to have a pen and a notebook in front of you. You keep writing, you keep solving, you keep calculating along with me, right? So according to my formula, what do I have? I have a 1, a plus b is 5, and a into b is 6, right? Simultaneously, if I do a 12 into 13, 12 into 13, I hope all of us already know the answer. I do not need a calculation, but I'm just writing it. Here the power common base is what? 10 power 1. So I have a plus 2, plus 3. What happens? Again, 1, 5, 6. But do you think these two answers can be ever same? Can the answers be same? Obviously not. There is definitely something that I'm missing out. What am I missing out is basically this n, right? The n that you have here, each of these blocks, remember, should have n digits. Each of these blocks should have n digits. Okay, if you already have n digits exactly, that is, each of these blocks should have 2 digits. If I already have 2 digits, great, I don't have to worry. If I do not have 2 digits, I have to somehow give it 2 digits or make it 2 digits. And if I have more than 2 digits, I have to shift it, like a carry forward, right? We'll see all of those options. Now, what happens in case of 12 into 13? I get 1, 5, 6. The n is 1. Each block should have 1 digit. Done. My answer is 1, 5, 6. This case, what happens? What is the issue here? I need to have 2 digits in each of the blocks, right? I have only 1 digit. How do I write 6 as a 2-digit number? Easy. 0, 6. How do I write 5 as a 2-digit number? 0, 5. This one doesn't matter because it is the extreme most digit. So whether you write a 0, 1 or a 1, it doesn't really matter. Your answer simply becomes 10506. Right? Was that clear? Probably the simplest step so far. We'll keep checking, like I said, as we do more problems from your worksheet. We'll keep checking more and more levels, like what happens when a shifting is there, what happens when more digits have to be shifted, and all of those variations we'll see. Is it clear so far? I want all of you to make a note of this, and also make a note that each block, each of the 3 blocks should have n digits. Yes, simple enough. Let's quickly solve these now. And we'll see, some of them might take a little time, some of them might happen quickly. Now, here, again, since we are doing it for the first time, probably I might be writing in a few steps extra, but over time, I want you guys to be able to write it directly without any steps. So here, simply, I can say this is what 10 square plus 7, 10 square plus 11, right? So what will I get? 1, a plus b, ab. This is 7 and 11. So this is going to be how much? 18. And 7 into 11, 77. Right? Do I need to make any changes here, or is it my answer? For the first question, 107 into 111, this is a 10 power 2. So I need to have 2 digits. I already have 2 digits. Great. So done. This is my answer. Does that make sense? Yes. Can you quickly try out the second one, all of you? And for the sake of the method, since we are learning a new method, let us try to do it with this method only. Wherever possible, I'll keep telling you other methods also. And I'm sure you may be able to do it otherwise also. But the idea is about how fast. Right? Diksha, don't worry, just hang on a minute. I'll repeat it once again. Vijay Kumar 10706, absolutely right. So we see this is 10 power 2 plus 6 plus 1, easy. So my A, the only thing you have to take care of is, if you want, you can make a note of your A and B. Like I said, over time, it will all become a mental calculation without putting pen on paper, right? So this is A is 6, B is 1. So I have 1, A plus B is 7, A into B is 6. This is a 10 power 2, so I need to have 2 digits, 0706. Right? Okay. Diksha, quickly recapping what we just discussed is, we are discussing the base method, where this is again applicable for numbers which are close to a common base. Others, you can go ahead and quickly try 3 and 4. So close to a common base or common power of 10. So if you say there are two numbers of the form 10 power n plus a plus b, you can easily do the multiplication by simply saying this column will have this column will have a plus b, this column will be ab, right? And each of these blocks that you see, I have divided my answer into 3 blocks. Each of these blocks, you should remember, should have n digits. Right? That is the reason, if you see, when we did 107 into 111, sorry, it was what? 10 square plus 7 plus 11. So what will be my answer? 1, A plus B, that is 7 plus 11, and A into B, that is 7 into 11. Now here the power is 2, and every block may I have to put 2 digits. I already have 2 digits. I did not worry. So done. Second problem that we did, the answer came out to be 1. A plus B was 7 and A into B was 6. It came as 1, 7 and 6. But here the power was 2. So I need to ensure that every block has 2 digits. So I made 6 a 06, 7 a 07. And 10706 becomes my answer. Right? Correct? Now, that's so far we've got. And like I said, when it comes to the fourth one, probably we'll learn another variation and so on and so on. Third one, let's quickly do. Again, this is a 9, this is a 13. 10 square is my base, plus 9 plus 13. So let us see. 1. 9 and 13 is going to be how much? 22. Now comes the tricky part. I need to do an A into B. 13 into 9. How many of you remember 13 table? Because if 13 into 9 itself is going to be a big calculation for you, then this doesn't help. And now 13 into 9, if you remember the tables, great. But any time, remember, any number into 9 is basically what? Number into 10 minus that number. So 13 into 9 is going to be nothing but 130 minus 30. Easy way to remember. Any number for that matter. 13 into 10 minus 13 into 1. That will give you 13 into 9, right? So 13, in this case, what would be your answer here? 130 minus 13 is 117. Now, understand here, what did I say? This is 10 power 2. So how many digits am I allowed to have in each block? Only 2 digits. So I have a 17 already. This one will get carried away, carried forward. So I have a 17. This will become 23. The 1 remains as it is. Right? 12317 becomes your answer. Everyone clear? Again, carry forward and all, these are your basic rules. Understand, it is not some magic that we are doing. The basic rules of arithmetic or, addition, subtraction, multiplication, those things remain the same that you had learned long back as kids, right? But just that we are looking at different ways of making it faster, right? So far clear, everyone? Can we move on to the fourth question and see what difference the fourth question will bring in? Fourth question, if you see clearly, one issue that comes up is a 98, right? So still, how can I write it? I'll write it as 10 square plus 5. And the other number, I can write it as a minus 2. We'll deal with the minus 2. We'll see how to deal with the minus. Right? So again, the process is still the same. 3 blocks. 1, a plus b. My a plus b is what now? The a plus b, remember, the signs could be anything, right? So you have to do your a plus b and ab calculation carefully. So this is going to be a 3 and this is going to be a minus 10. So when the first time I put it down, it looks so vague, and because minus 10 in the middle of my answer doesn't make any sense. I somehow need to get rid of this, right? Now, remember in subtraction, when you were learning subtraction, what do you do when you get a subtraction like this? For example, if we are doing 25 minus 80, very simple example I've taken. When I have to do a 5 minus 8, I clearly have a smaller number on top. What do? I borrow, right? I borrow. Now, one more logic. When I borrow a 1 here, does this 5 become 6? Does this 5 become 6? No, this 5 becomes a 15, right? When I borrow a 1, this 5 is becoming a 15, right? And then I do a 15 minus 8. And then I have to give back the 1 here. The same logic, the same funda works here also. Let's see now what. Whenever you get a minus in the middle of your answer, try to remove it by borrowing. Okay? Now comes the tricky part. When you borrow, what is it that you're borrowing? Right? Here it was easy. When I borrow a 1, it was as good as saying I'm borrowing a 10 because 5 became 15. Here in this method, when you're doing, always remember your borrow is equivalent to your power. The entire base. Your borrowing is equivalent to your base. So if I'm borrowing a 1, it is equivalent to borrowing a 100. Is this understood? Again, trust me, the first time it might seem all a little, weird and tricky and all of that. But once you get a hang of it, it's going to be really simple. Okay. So what do I need to do? Everything looks okay to me. I just need to get rid of this minus 10, right? So like I said, I need to borrow. So this is now equivalent to saying 100 minus 10, which is a 90. Okay. Then now I took a 1 away from this 3, right? So this will become a 2. Same rules of subtraction, right? Now I have a 2 here and my power is 2. So I need to put it as 2 digits. So I write it as a 0, 2 and the 1 comes on as it is. So 10290 is your answer for the fourth one. Do we get it? Right? So first thing we saw, this is your general method where each block should have n digits. And in case you have a minus coming up somewhere in between, you need to adjust it by borrowing. Remember, you could have minus at both places. In case you have a minus here also, again, you need to borrow from the next digit and so on. It will continue. Clear so far? Let's try out a few more problems and see a few more variations. I want you guys to do the fifth one. Sixth one quickly, all of you. Okay. And like I've been saying, for the sake of this class, since we are learning new methods, as much as possible, try to practice out these methods. Like I said, end of the class, you have so many methods, you want to do it in a different way, that's up to you. But since we are learning, we'll try our best to stick to this method when we are practicing, right? So again, simple, this is a plus 3, this is a minus 8, right? So 1, a plus b is going to be what now? A plus b is going to be a minus 5. A into b is going to be a minus 24, right? So let me adjust this now. You have to be a little careful. This, like I said, is 100, right? So 100 minus 24 is 76. Now this minus 5 gave away minus 1. So remember, it's not going to become minus 4. It's going to become minus 6. Remember that. That is one error that might happen. But remember that there's a minus sign here. Right? Now minus 6 also I need to adjust. So same. 100 minus 6 is nothing but a 94. Right? And the first block, 1 gave away 1. So this is 0. So there's nothing. So what is my answer? 9476. And that's it. Clear? Yes. 91 into 87, I'm putting a star here. I will do it right now with this method, but by the end of the session, if you want to do it in the other method that we'll be discussing, that's also absolutely fine. But for now, let's try to do it. This is going to be 100 minus 9, and this is going to be again 100 minus 13. Still, 13 and 9 are still easy, doable numbers, manageable numbers, not too difficult. Same thing, 1. A plus B is going to be how much now? 13 and 9 is going to be 22, minus 22, remember. And 13 into 9, we just did that in a previous problem, 117. Without the minus, you have 2 minuses, so that is gone. Right? Base is what? 10 square. Now, what do I have to do? I need to take care of this 2 also. At the same time, I need to take care of this 3-digit and those shifting and everything also. Right? So what happens now? This one, if you see, I already have one. Harika has already given me the answer 7917. I want all of you others also to try out and tell me the answer. I've already given the first step. See what answers are you getting? 7917. Same again, you can do it in the same way. This one has to be shifted. So it is minus 22 plus 1, meaning a minus 21. Right? I have a 17 here. Right, now same thing again. This has to be borrowed. So 100. 100 minus 21 is nothing but a 79. 7917. This 1 gave away 1. So it is a 0. 7917 becomes your answer. Clear so far? Yes. 7th one is an interesting question. I want all of you guys to try out. I'll give you 30 seconds. Try the 7th one. Okay, Harika, good. 982077. All of you, try it on your own. I see some of you have put up answers. Try out the 8th one also. Those are done with the 7th. Perfect. See, good. Now you understand, if you pick up the right kind of questions, you'll see the power of this method. Going forward, you'll see every step there is some extra additional calculations getting added up, but we'll see when we get there. So again, this is what? 10 power 3. So 993 is what? Minus 7. 989 is minus 11. I hope all of you understand that part. 7 and 11, easy numbers to deal with. I can still go ahead and write this. Right. Okay, Harika, I think you've given the answer for the next one. Good. Okay. So same thing. 1. A plus B is going to be how much? 7 and 11 is again both with a minus sign. So minus 18 and 77. Right. Now what do I need to do? I have a 10 power 3. So my last block will become 077. I need to get rid of this minus 18. So I will borrow. Remember, what are you borrowing? Don't be in a hurry. This is 10 power 3. So when you borrow, it means you're borrowing 1,000. When you borrow 1, it's equivalent to borrowing 1,000. So 1,000 minus 18 is what you have to do, which is a 982. My first block has 3 digits. Second block has 3 digits. First block the last one gave away 1. So that is 0. So 982077 is your answer. Right? Let's quickly look at the 8th one. Again, the same story. 10 power 3 plus 13 plus 17. Again, real understand the plus 13 plus 17, 10 power 3. All these things I'm writing just because we're in the beginning. Over time, you guys need to avoid doing that also. Get to the point right away. Right? So 1. A plus B is what? 17 plus 13 is 30. Now, 17 into 13. This is itself a good calculation. Now, 17 into 13, if you already know, I'll also teach you a method towards the end of the class. We can directly write it down as 221. 17 into 13, if you know, great. Or 17 and 13 itself, you can do it with the base method if you see. 17 and 13 is like 10 plus 3, 10 plus 7. So that itself can be done by 1 AB a plus b. 1 a plus b ab. You can do it in that order. But if you know, great. Like I said, 17 into 13, we'll look at a different method also towards the end. Right? So I have 1, 3, 0, 2, 2, 1. What is wrong? I need to give an extra 0 here. So 1, 0, 3, 0, 2, 2, 1 becomes my answer. Clear so far, everyone? Yes. Now, I understand the next question that might be coming up in your mind is what happens when I have this things like this. 50, 70s. What happens then? I have a 200 here, I have a 400 here. What happens in that case? Right, now, first things first, understand, since we are doing the base method, that is why I'm going to explain these steps also using the base method. But remember, for all of these questions, the other method also works, the one that we'll be looking at later. Right? But right now, we have to understand the base method. We have to learn it in entirety. We can't just learn it in half. That's why I'm going to go ahead and explain it. Here, what is the problem that we are facing? It is common. If you see 56 and 61, it is close to a common number, but it is not close to a common base of 10. In fact, it is close to 60. This one is close to 70. This one is close to 200. This one is close to 400. Right? So not only these numbers are not directly close to a 10, 100, 1000, they are some other multiple of 10, 100 or 1000. So the difference that comes in is earlier we were writing the numbers as 10 power n plus a plus b. Now this where 10 power n was your base. Now your base simply becomes m into 10 power n. Okay, m into 10 power n. So this I can call it as 6 into 10 power 1 plus 1 minus 4. 7 into 10 power 1 plus 4 plus 2. That way. Again, this one, remember for the ninth one, you can either take 50 as the base and write plus 6 plus 11. Or you can take 60 as the base and write it down as a minus 4 plus 1. Either ways, it's going to work absolutely fine. We'll do one method. You can try out the other method later. Right? So the first step remains the same. I have a 1, a plus b and ab. This doesn't change. But my m has to play some role, right? I need to adjust this factor in this m somehow. What do? Each of your blocks will get multiplied by a power of m. This is m power 0. Don't worry, it is ultimately 1. This is m power 1 and this is m power 2. Again, don't worry, the bigger calculation m square is ultimately being multiplied by just a 1. So it's not going to be too difficult. This is simply an m into whatever we get here, and this is going to be 1 into whatever we get here. So it is not going to be so tricky. Clear? And then the last step of shifting, adjusting, that still remains the same. Again, the n digits also remains the same. Remember, every block can have n digits only. That rule doesn't change. Whatever we have learned so far, every step remains the same, except an additional step comes in. We have to adjust this in. Clear? Let's try out the ninth one then accordingly. I'm using a 60 as a base. Like I said, go ahead and try it out using 50 as a base. You'll end up having the same answer. It's not going to change, right? So what am I writing? I'm writing 60 minus 4 plus 1. Right? So like I said, 6 into 10 minus 4 plus 1. So how do I write my three parts? You can also keep solving simultaneously along with me. So this is going to be a 1. A plus b is going to be a minus 3. AB is going to be a minus 4. Right? Now, what did I say? I need to adjust for the m, sorry. So this is going to be, like I said, minus 4 into 6 power 0, that is same. Minus 3 into 6, so this is going to be a minus 18, and this is going to be a 36. Clear so far? Yes, now again the same logic of carry forward has to work. And remember, the power is only 1, so I need to have only one digit in every block. Right? So 18 will give away 1, so this is going to be a 10 minus 4, so I have a 6. 18 gave away 1. It was already a minus 18. So this will become minus 19. Right? Clear so far? Now, a little tricky. Remember, if I borrow 1, What happens? I'm borrowing only a 10. Is it enough to remove my minus? No. So I have to borrow 2. I'll borrow 2 as in I'm borrowing 20. 20 minus 19 is 1. And 36 say 2 gone, 34. 3416 becomes my answer. Again, first time we are doing, so yes, it is taking a little bit of extra steps. It is taking a little bit of time. But I'm sure over time this will happen faster. Like I said, if you want, go ahead and try it out as a 5. 5 into 10 power 1 plus 6 plus 11. That might work a little faster because you wouldn't have a minus to deal with. Right? Okay. Let's try to understand this once again. Okay, this is taking too much time. Let me try to explain it on the board. So we have 56 into 61, right? So I want all of you to look at this again. 56 into 61. So I'm taking it as a 6 into 10 power 1 plus 1 minus 4. Clear so far? One of them is 56, one is 61. What am I supposed to do? 1. A plus B is going to be minus 3, right? AB is going to be minus 4. Clear so far? I need to adjust and accommodate this m factor in. I have to multiply by m power 0, m power 1, m power 2. M power 0 is nothing but a 1 only. Now, so you can always remember anything that you're multiplying here, this is you're multiplying with a 1 only. It is going to come back as it is. Right? So minus 3 into 6 power 1, which is nothing but minus 18. And 1 into 6 power 2, which is a 36. Right? Now I have to adjust and get rid of all these minus signs. So I'm going to borrow. What is my power here? 10 power 1. So borrowing means borrowing a 10. Borrowing 1 means 10. So this is 10 minus 4, a 6. Okay. Minus 18 gave away a 1. So this became minus 19. Now I have to get rid of this minus 19. If I borrow only 1, meaning I'm borrowing only 10. 10 minus 19 is still going to give me a negative number now. So I have to borrow 2. Borrowing 2 meaning borrowing 20. 20 minus 19 is going to be 1. This 36 gave away 2. Meaning it became what? 34. So my final answer becomes 3416. This is 1, so each block needs to have 1. Remember the first one, the extreme corner, if you have two digits, that's okay. We never have to make it 2 digits. At the same time, if you have 2 digits, there is no way to shift it, right? There's no way to carry forward. So here, whatever, any number of digits is allowed. But for the other 2 blocks, remember, it is always going to be n digits, right? Again, I'm repeating this. 56 and 61, remember, once we do the other method, you might realize that it is better to do it with the crisscross method as compared to the base method. Base method, always remember, it has its own restrictions, but within those restrictions, it works wonderfully fast. Right? So the M method, just for the sake of completeness, understand how to do it. But whether you want to solve it with this method or not, it's a different thing. At least you should all know. Can you all solve 74 into 72 similarly? (74 into 72), can you guys try it out? While I try to erase this. Okay. 74 into 203 into 195, don't worry, it will still be simple. Yeah, okay, Sindhuja, okay. 74 into 72, you think it is 5328. Okay, fair enough. Let's quickly check. 5328 again. Okay. So again, okay, the symbol doesn't seem to be changing anyway. So I have 7 plus 4 plus 2. This should still be simple because there are no minus and all of those things to take care of. This will still be okay. So I have 1. A plus B is what? A plus B is 6. A into B is 8. So again, I need to quickly multiply with the 7 powers of 7. So this is going to remain 8. This will become 42. This will become 49. Clearly the power is 1. So digits have to be 1. So I have an 8. This 2 will remain, this 4 will go away. 49 plus 4 is going to be 53. 5328. Clear, everyone? Not that bad also, right? It's still manageable, right? 203 into 195. Can you guys quickly try? Again, hint, you'll take it as 2 into 100 plus 3 minus 5. 2 into 100 plus 3 minus 5. Right, let's give it a try. 39585, Harika. Good, very good. 10 square plus 3. Again, like I said, all of these writing and all of that can happen in your mind over time. That should happen. You can probably start writing down from the first step directly, right? So I'm writing. I hope you're all already done by now. 1, again 3 and minus 5 will be a minus 2. This is going to be a minus 15, right? So this will remain a minus 15. Multiplying by powers of 2. This will be 2 into 2, so minus 4. This will be 1 into 2 square, so 4. Now let's try to get rid of all the negatives or the minuses. So this is 10 power 2, remember? So borrowing meaning borrowing 100, right? So 100 minus 15, 85. Minus 4 became minus 5 already. And 4, again, it will borrow 1. So 100 minus 5 is a 95. And then 4 became 3. 395.85 is your answer. Now, one thing I want all of you guys to focus on, at least in the beginning, is when you're learning these, the word itself says speed calculation techniques, right? So you have to be fast at it, right? So in the beginning, please focus on the speed. It is okay if you're getting a couple of digits here and there error. I'm fine with that. I'm not saying go ahead and make a calculation mistake in your exam as such, but what I mean to say is in the beginning, focus should be on the speed. Try to do it as fast as possible so that, the method will sink into your minds. The faster you do, the more number of problems you solve, the method will sink into your mind. Initially, if you're going wrong with a few digits here and there, I'm still okay with that. Over time, you will be able to overcome that. Accuracy will follow. Remember, focus on speed first. For speed maths, this is particular advice for speed maths. Accuracy will automatically follow with practice. Right? So don't spend too much time on focusing on the method. Ki, array, should this happen? Should that happen? Go ahead, keep solving. At the most, you get one digit wrong, you can quickly correct yourself. Right? 11th one, was everyone able to get? 12th one, go ahead. Give me an answer for the 12th one. The simple 4 into 100 plus 9 minus 9. 4 into 100 plus 9 minus 9. Good, very good. So again, the same one, a plus b, ab. Now, a plus b plus 9 minus 9, 0. Good for us. Minus 81. Right? Again, I have to deal with the 4, the m. So this remains minus 81. This 4 into 0 will be 0. And this will become 16. Right? So now next what happens? This is going to give away 1. So that is going to be your, again, this was 100. So 100 minus 81. 100 minus 81 is a 19. This became a minus 1. I'm giving it a 1. So 100 minus 1, 99. 16 will become 50. 159919. Sorry. You'll realize that right now, even if you think that this is taking a little time, imagine doing a 3 cross 3 multiplication in your traditional method. That is still going to take a lot more time. This is still definitely better. So like I said, focus on the speed. Try to do it as fast as possible. Accuracy will automatically happen. 13, 14, 15. Can you guys quickly finish it off? Very, very simple. When you look at these bigger numbers, you'll actually start realizing how good and how easy this method is. Try out 13, 14, and 15. I'll give you probably a little more than a minute. 1 to 1.5 minutes, not more than that. I'm also writing it down here. I'm calculating it, but I want you guys to calculate it on your own and put up your answers and then check. Okay. Keep solving all the three. Keep solving. I'm seeing your answers. You can check the answer on the screen as well. In case I'm making a mistake, please let me know as well. Good, correct. You see, 14th one was so quick to solve. It was so easy to solve. Just keep a track of the power of 10. That will help you figure out a lot about the number of digits and all of those things. Okay, 15th one. I'm waiting for you guys to also put up the answers. Okay, I think the last one was slightly tricky. Vijay, just check it out. Which answer have you put up? 403901 is 3995901. Yes, that seems to be the answer. Right, again, yes, a little careful this one. Like I said, 2 into 1000 minus 11 plus 9. Okay, so 1 a plus b ab. Then I have to adjust the m. Into 1 is 99, into 2 is minus 4, into 2 square is going to be a 4. Then keep adjusting. I'm borrowing a 1, meaning I'm borrowing 1,000 here. You know, 1,000 minus 99 is a 901. This became a minus 5. I borrowed again a 1,000 minus 5 is 995. And the 4 gave away 1, meaning it became 3. Okay. 3995901 becomes the answer. Clear, everyone? Now, so far clear. So what is the base method? We understand. We write down everything in the power close to a power of 10 power n. And if needed, we also add another m to it. So the base m into 10 power n plus a plus b. This is how we write it down. Your 10 power n is usually known as, referred to as the primary base. M is your secondary base. Then we do the step 1 a plus b ab, and then we adjust with the m's. We start multiplying from the other corner, m power 0, m power 1, m power 2, and then whatever shifting is needed, we do that. That is the end of the process. Now, if you understand squaring, if you see what do we do in a square, we are multiplying the same number twice. So don't you think whatever we just learned about the base method to multiply any two numbers can be very well applied to my squares also? For square, what will happen? I'll simply write, if it has m, it has, otherwise not. 10 power n. Let's say this is plus a or plus x plus x. Both a and b are the same numbers basically, right? So take it as x, take it as a, up to you. So what happens? 1 x plus x will become 2x and x squared. That's it. Everything else, every other step, every other process remains the same. Okay. Now, squaring, there are multiple ways to do squaring. I'll discuss a few others also, but since we are practicing, like I said, since we are practicing the method, let's try to do a few with this. Remaining you can solve later at home. Try doing 94 square using this method. I'll tell you how else to do it also. But let's try 94 square with this method that we've just done. All of you quick. Again, don't do a 9 into 10 power 1. Rather do it as a 100 minus 6. You'll realize that is much faster. Perfect. Again, using the same method, I'm also quickly writing it down. Don't worry, Vijay, we'll solve it together. 94 square, what is it? 94 into 94. And so whatever we are doing so far, 10 power n plus a plus b, instead of two different numbers, it is the same number now, plus a plus a. So my method remains the same, 1. So this is what? 10 square minus 4. Again minus 4. Both of them are the same numbers now. So what happens? 1. A plus b is going to be what? Minus 8. AB is going to be positive 16. Right? I'll do the same thing. 16, no problem with this. This is power 2. Every block should have 2 digits. So 16 is doing just fine. I'll leave it. Minus 8, I need to get rid of the minus sign. So this will borrow 100. 100 minus 8, what is it going to be? Okay, did I do something wrong or did you guys go wrong? 8836 was the answer for which question, guys? Yes, probably I've gone wrong somewhere. Let us, oh, sorry, this was a 6. So sorry. See, don't do these mistakes. Can actually, yeah, this is 94 is actually 100 minus 6, right? So 6 and 6, this is a 12, right? And 8836 is actually the right answer. So good. And here I'll have 6 and 6, 36, right? So yeah, the 36 remains as it is. 100 minus 12 will become 88. 8836 becomes the answer. Clear? Can you guys quickly do the 20th one? 200 minus 3, 2 into 100 minus 3. Try to do that. We'll probably quickly discuss some other ways of also doing squares, but like I said, just because we're doing this method, we'll go ahead and do it in this method. So there's a minus 3. Yeah, I took it right this time. So I have a 1, minus 6, and a 9. So this is a power 2. So 0, 9. And I have to take care of this 2 also. So this is a 9. This is a minus 12. This is a 4. So 0, 9. 100 minus 12. 88 and 3. 38809. Anil, can you check? Vijay, can you check? I think you have posted the right answer again. 38809 should be the right answer. Clear? Now, does anyone know any other method of squaring? Forget the base method. 49 square, if I ask you. For the base method, you might want to do 4 into 10 plus 9 or 5 into 10 minus 1. All of that is fine. But is there any other method to find 49 square really quickly? 50 square minus 1? No, 50 minus 1 whole square. Harika, understand the difference. 50 square minus 1 will not work. So understand, remember way back in school, a plus b whole square, a minus b whole square formula you had remembered, right? I mean, at that time, probably you just memorized it even without understanding why even we are, doing that. But all of these, if you see 49, 67, you can easily put it up in your a plus b or a minus b formula and go ahead and solve. Like I'm saying, just an additional method. No hard and fast rule. Maybe for 197, this is working faster. Or for 197 also, you could do a 200 minus 3 whole square. So what was your, for example, if I have to do 49 square using that method, what am I saying? 50 minus 1 whole square. Again, not the base method. Base method, we have done enough examples. So these, for practice, I want you guys to try it with base method back at home. But otherwise, you can simply do it as a 50 minus 1 whole square. What is a minus b whole square? A square plus b square minus 2ab. Right? That is one way to go about it. Or you could do it as a 40 plus 9 whole square. Again, a square plus b square plus 2ab. That will also work. Clear, everyone? For again, understand base method will work wonderfully well when you're close to direct tens or hundreds or thousands. Whenever the m factor comes into picture, things might get a little tricky. 94 square, like I said, you could do it this way. Base method is also working quite fast, easily. 8836, we got the answer really quickly, right? 100 minus 6, so 12, 36, it's all easy. Or you could also do 100 minus 6 whole square. That way also you can solve. But understand and appreciate the base method for numbers which are close to tens or thousands or hundreds or 10,000s. You can do that faster. Okay, let's try out a few more examples. 104 square, can you guys do? It is going to be happen in like seconds. Within a matter of seconds, you'll have the answer. 104 whole square. You can do it almost verbally. You need not do any calculation. 104 whole square. 104 whole square, if you see, doing it by 100 plus 4 whole square using a plus b whole square formula is also going to take a little time. Base method is going to work absolutely fast. What is it? 100 plus 4. So a plus b, ab, that's it. Since it was 100, I need to give 2 digits. So if you realize, it happens in 10 seconds. So some questions will happen that fast. You need to be able to realize and use it. Okay, can we do this? 996 whole square. So it's like 10 power 3 minus 4. See, wasn't that really fast? Can you, think of solving 996 whole square using any method so fast? No. 1 minus 8, 16, that is a plus b, ab. And all I need to do 16, this is power 3, so 0, 1, 6. Minus 8, I need to eliminate the minus. So I borrow 1000 minus 8, 992. End of story. Right? Very quickly now, again, 30 seconds, do the 25th one. There is an m factor coming in, but nevertheless, it is still simple. See, good. 9012004. Absolutely. Very good. Very good. All of you. Good. 21 and 22 might take a little extra time. Not as simple as maybe 23, 24, 25. But still, it is not going to be too difficult either. These two you can try it out later. 2 into 10 power 2 minus 5. Sorry, 3. 3. Don't make that mistake. 3 into 10 power 2. I'm taking it as 300 minus 5. That way it is easy. Again, here it will be 4 into 10 square minus 4. So probably, yes, quickly 3 steps will happen. You'll still be able to do. Not as simple as these 3, but yet not too difficult either. Clear with squares as well. Like I said already, use base method for these kinds of questions. For maybe a 49 square or a 67 square, those things you might still go back and do your a plus b whole square formula. That also works for you. This is probably slightly, we're trying to find cubes. We did base method. We used base method to find squares. Now we are doing base method to find cubes. Okay. Now, so far, if you see, whether it was normal base method or it was squaring, we were multiplying two numbers ultimately. Some number into some other number. When it comes to cubes, understand what are we doing? We are going to multiply three numbers. Right? So certain things are definitely going to change. The overall method, the broad method remains the same, but there'll be a few changes here and there. Let's try to understand. Right, so the first example that you had was 77. I'll do the 109. That will be a little simpler. Or you could do any number for that matter and try. Okay. Now, what happens is, again, the same thing. I write it down as 10 power n plus a. Ultimately, the three numbers are going to be what? Plus a, plus a, plus a. Right? And if there is an m, you deal with it. If not, we don't deal with it. Simple. Now, so far, because it was only a multiplication between two numbers, I divided my answer into three blocks. For a cube, I'll have more number of digits. So I'm dividing it into 4 blocks. Remember this, the 4 blocks comes in only for the cubes. Okay. Now, if you remember a little thing, for squares, what did we do? What happened in my 3 blocks? I said this is 1. This was x plus x or a plus b. So 2x. And the last one was x square or a square. Can you identify what this is? 1, 2x, x square. Isn't it same as a plus b whole square in a way? A plus b whole square formula. A square, b square, 2ab. So the same funda happens for a cube also. Right? Cube, we simply write it down as if it is a 1 plus a whole cube. What I mean is, this is a 1. This is a 3a. This is a 3a square. And this is an a cube. Okay, this is probably one step slightly different because base method we learned it from the beginning, 1a plus b ab, and that worked absolutely fine for the square, 1a plus b ab. For cubes, we need to remember slightly different. Okay, so this is one step you can remember. Rest everything is the same. Multiply by m power 0, multiply by m power 1, multiply by m power 2. But again, I have still one more block left, so I have to multiply by m power 3. Rest everything remains the same. Okay, make a note of this and let's do 109 whole cube as quickly as possible. Simply, I need not write down anything. It is 10 square plus 9. So what am I supposed to write? My A is nothing but 9 here. Right? So 1. 3 into A is 27. 3 into A square. A square is what? 81 into 3. You have to be a little careful in these calculations. 81 into 3 is not difficult at all, 243. And A cube, that is 9 cube. 9 cube, I hope all of you already know, it is 729. Right? I only need to do what now? There are no minus signs to take care of. But since this was 10 power 2, I have to shift these. Right? So I'm left with a 29. This will become 243 plus 7. So 250. I'll retain the 50. I'll push the 2. 27 plus 2 will be 29. No problem. And the 1. Was this okay? Did we all understand? Take a couple of seconds, go through this once, and then you can try to solve. We did 109, right? Try solving 994. 994 whole cube. Take a look at this, note it down, understand the process, and then do 994 whole cube. So earlier we were doing 1 a plus b ab or 1 2a a square. Now we simply need to do 1 3a 3a square a cube. Like I said, also another way to remember it is, this is nothing but a 1 plus a whole square, whole cube, the formula. 1 cube plus 1 square a, 3 into a, 3ab, 3ab square, that formula basically. 3a square b, 3ab square plus b cube. Right? Even if that confusion is taking a little time to sink in, you can just remember this. Right? Can someone tell me the answer for 994 whole cube? I hope that was the number. 994 whole cube. Nine nine four whole cube. What do you think it should be? On your own, everyone. I'm writing it down here, but try to do it on your own first. So this is going to be 10 cube minus 6. So my A is basically 6. Minus 6, sorry. So 3A. 3A square. A square is 36. 36 into 3. So 108. And cube 216. Don't get too worried about the big minus and the big numbers. Imagine in a single step, or in 2 steps rather, you're able to find out the cube of 994. There is no other way where you could find this so quickly. Right? Adjust the minus. That's all we need to do. Quick pick. I'm waiting for an answer. Again, here in this case, when you're borrowing 1,000. 1,000 minus 216. So 816 gone. So 784. Right? 108 will simply become 107. No problem there. 18, again, the minus has to be taken care of. So 1,000 minus 18 will be 982. The 1 gives away 1, so that is gone. 982, 107, 784. Good, Kavya. Yes, that's correct. 982, 107, 784. Yeah. Again, understand this also. While the normal base method and the squaring method, you might use it more commonly, finding the cube of such big numbers might not come in as a part of a common calculation, but it is something good to know. For example, when we do percentages, I'll probably take this example might make more sense. That's 109 whole cube. If something is, let's say, increasing by 9%, so you 9% and 3 consecutive years, let's say. So what do? It becomes 1.09, 1.09 into 1.09. So those cases, yes, you might want to use these techniques to help you solve the calculations faster. Right? So understand the method, practice it out, but ensure you know which method to use for which kind of problem. And in the beginning, even if it is taking a little time, even if it is confusing, don't give up on it. It is not going to happen in one day or 1 week. It needs regular practice. Clear, everyone? So probably, like I said, you can note this down, this part. Please ensure that you note it down. And the rest of the things remain the same. Clear? 26, 29, 30, you could probably try it out later. Yes, clear everyone? Can I get a quick yes? Somehow 994 whole cube, all of you fell, okay, I can't do it, kind of. Only Kavya gave me the answer. I hope the others also solved it, even though you didn't type it. Shall we move on to the next method? Okay. Yeah. This is the general formula for the cubes. M into 10 power n plus a plus a plus a. I'm writing it down only once. So you have 4 blocks instead of 3. So it will be filled in 1, 3a, 3a square, a cube. And then you need to multiply by m power 0, m power 1, m power 2, m power 3. And then every other rule, every other shifting, borrowing, adjusting the minus, all of that remains the same. Right? So, shall we move on then? Right. Okay. Now, here, if you see, somehow these numbers are also close to 20, 70, 40, and 60. Somehow it happened so. But let us now go ahead and look at a different method. Right? A slightly different method. Let's try to solve that and see. Now you'll understand. Even earlier, if you see some of the numbers 56 into 70 and all of that, I told you it is easier. I mean, I think these 67 square, like I said, or a 74 into 72, 56 into 61. If you remember, I told you can do it in other methods also. Now, base method, like you saw, works really fine, really wonderfully fast, but it has some restrictions. Key numbers have to be close. If I have to, for example, do a multiplication 64 into 93, I cannot possibly do it with the base method. What will I do? 100 minus 7 and 100 minus 36? No, doesn't work. Neither can I take 60 as a common base or 90 as a common base. None of that works. So base method, you understand, works very fast when it is close to 10, 100, 1000. Or it also works fast when it is common to a multiple of that. M into 10 power n ke paas, it will still work. But for numbers which are very far off, right, far away from each other, there's no common base that you can bring it closer to. There's another method that we look at, which is known as the general method or the crisscross method or the cross multiplication method. Cross multiplication method, please understand and make a note that there are no restrictions. Any two numbers you can go ahead and multiply without any problems, without any restrictions, without any rules. Right now, like I said, by chance the numbers that you see here are also, can be solved with base method as well, but we'll go ahead and look at the crisscross method now. Right, so let us see how to solve this now. Typically take any number AB into CD, any 2 cross 2 multiplication. Now for base method, if you see, the power of 10, the n, that determine the number of digits in each block and all of that, right? How big the number will be and all of that. But for the crisscross method, you will see a 2 cross 2 multiplication. 2 cross 2 meaning 2 digit into 2 digit will have slightly different rules as compared to a 3 cross 3 or a 4 cross 4. The first step itself will be slightly different in each of these cases, but don't worry, it is going to be a very simple case. Right? How you solve it is, now you can either write it down or practice writing down the two numbers like this or in this manner. Either ways, whichever is convenient to you, you can take a look at that and accordingly. Now, if you see in simple words, this is a units digit, this is a tens place. When you're multiplying two two-digit numbers, right, my answer will be at the most what, tens into tens digit, right? I can split my answer into 3 blocks. Right now, basic funda you have to remember. Either you can remember it visually, crisscross method, one thing good about it is you can also remember it visually, but you can also remember it conceptually. How will this number be filled? Units, this is the units place of your answer. This is, let's say, the tens place of your answer. This is the hundreds place of your answer, right? How does the unit digit come in? When you multiply the two things in the unit digits, unit places, right? The two digits that you have in the unit places, BD. Simple. How do you get the tens place, tens digit wala number? How does it come? I can multiply the 10 with the unit, or again this 10 with this unit. Do we all understand this? So what am I essentially doing? Criss cross. A into D, this is the tens digit into ones digit, and this is another tens digit into another ones digit, right? So I'll get it as AD plus BC. Again, don't worry too much about the ABCDs here. You only need to write this down once for understanding. Once you know the logic of the crisscross, from where it is coming, it will become really easy, right? And where will my hundreds digit come from? Tens into tens. So AC. Clear? If you see, this again is no magic at all. This is just a simplified step of your regular multiplication. Regular multiplication, if I'm doing a 23 into, let's say, a 42. Simple multiplication. How do? I do a 2 into 3, 6. Yes. Then what do I do here? 2 into 2, 4. Next step, what do? I put a cross here. For some reason, we were taught to put a cross here, remember? Then we start with this 4. 4 into 3, 12. I write down the 2 here and take down the 1. Carry forward. And then I again do a 4 into 2. The 2 tens digit, 8 and 9. What is happening? This 6 came from what? This 6 came from 3 into 2. That is your BD. This 4 plus 2, how am I getting this 4? What did I do? I multiplied this 2 into 2 and 3 into 4. Ideally, it is what? A 12 plus 4, right? Just that the 1 is going to get carry forward. The same thing you'll apply here also, right? So this 6 is nothing but a crisscross from the 10 into 1 and 1 into 10, right? And finally, how did I get this 9? 2 into 4, 8, and then a 1 from the next digit. Clear? So this one, if you see, is just a one step shortcut of writing all of this in one step. Do we understand this? Yes. So probably I'll write it down slightly more neatly so you all can note. So anytime I have an AB into CD, answer into 3 blocks, BD, AD into BC, AD plus BC, and AC. Clear? Remember here, every block can take only one digit. It's not like there is no 10 power n which will decide now how many digits can come in and all of that. So every block, simply put, can take only one digit, except this one. This can take in extra, like we all know. So anything extra that comes here, you push it to the next. Clear? Now, again, like I said, this is one way visually to remember it. So, you know, AD, BD comes here, AC comes here, and a crisscross comes in the middle. Another way, probably you can write it down here also, even if you are, like I said, writing it down in a horizontal manner. That way also works fine. You know, this is the ones digit, this is the ones digit. You know that. So you write down BD. Right now, how do you figure out the middle term? Middle term is nothing but A into D, B into C. So if you're writing it down like this, another way to remember, again, I'm giving you multiple ideas, multiple hints. You do it whichever way suits you best. This is what product of extreme and product of middle numbers. AD, BC. Isn't that what we got here? AD, BC. Right? And the last one is obviously going to be 10 into 10 AC. So whichever way you choose to do it, it is still going to be the same. It's just that how comfortable you are with which variation. Clear? Can we quickly solve a few 2 cross 2 then? Can we quickly solve these 31, 32, 33, 34, 35? We'll do it later because there's 3 digits. So let's do 21, 20, the 31 to 34 quickly. Again, as much as possible, try to reduce your calculations. Again, when you write down the middle term, ensure you calculate the entire thing in your mind and then write it down. And so at least you're saving up one step. Don't write it down AD plus BC like we had written it down. AD plus BC, we wrote it down for us to understand how we are getting it. But otherwise, you see, how will I get my middle term? 2 into 2, 4, plus 1 into 2, 2. So 4 plus 2, I directly write down 6. And 2 into 2, 4. 462. Clear? So whether you understand horizontally or vertically, that is up to you, because both ways are going to work out absolutely fine. It just depends on your comfort. I'll write down the answers here while solving. I want all of you to solve as well. It wouldn't take too much time at all. I'll give you around 30 to 40 seconds. Let's try till 34, 32, 33, 34. All of you, in case any one of you is having a doubt, please feel free to ask. I hope you guys are able to solve. Yes, so you guys done? Yes, I think 69 into 64, you're right, is 4416. It should be 64. Is it clear, everyone? Are you guys able to do 31 to 34? Anyone having a doubt, please feel free to ask. Again, like I said, over time, again, right now, since we are doing it for the first time, probably, it's okay that you write it down like this, right? But over time, try to write down the final step directly. If you see, this is less complicated as compared to the base method. In a base method, you had to write down because there was M to take care of, there were minuses to take care of, and all of that. Here, you wouldn't have any of those issues. The only thing here you have to take care of is the carry forwards. Right? So while it is okay in the beginning to write it down and then do another step, but over time, try to do it in a single step. Let's try to understand that also. 69, 64, how will we do it? What I'm trying to say here is, for example, 9 into 4, what do we have? 9, 4, we'll have 36. Then next, what we'll have? 9 into 6 and 6 into 4. right? 6 fours are 24, 9 6 are 54. 54 and 24, write it down directly as 78. And then I have what? 6 into 6, 36. From this, I take up this step. 6, 3 goes here, 78 becomes 81, 1, and 8 goes here, 36 becomes 44. Is it clear? When I say try to write it down directly, what I mean is something like this. When you say, okay, 9 into 4, 36, write down 6, carry a 3 here, right? Carry the 3. You know the 3 is going to be added to the next block. So what is happening? How am I getting the next block? 6 into 4, 24. 9 into 6, 54. 54 plus 24 is 78. 78 plus 3, 81. Write down 1, carry the 8. Then write down 6 into 6, 36 plus 8, 44 directly. I hope you understand. Clear? A lot of mental calculation, but you see that they're simple ones. Doing 6 into 6, 9 into 4, these are not difficult calculations at all. Clear? Is everyone thorough with this method? AB into CD, 2 cross 2 crisscross. 35 will come back, we'll understand, because there are 3 digits. Right? All these have 3 digits. So we need to see how to solve 3-digit numbers. Right? Now, okay, I think I have to open a new board. Right. So a 3-digit number, what happens? I say A, B, C and D, E, F. Okay. Again, like I said, crisscross method works in a good way, in the sense that visually you remember. I do not want any of you to memorize the ABCDs, because if you write ABCD in a different order, then the whole thing is gone. So don't memorize it like a formula. Understand it more in terms of the places, units, tens, and hundreds. Right? So same way, let's take a look at what happens when I'm trying to do a 3 cross 3 multiplication. Right? Again, the same story. So far, if you see, I had tens units. When I multiplied the 3, I was expecting a unit, tens, and a hundreds. Right? But here, if you see, this is a 100, this is a 10, this is the unit place. So the final ultimate 100 into 100, right? 100 into 100 meaning the final term could be 10 power 4. 100 into 100 is like 10 square, no? So 10 power 4. So meaning I'll get a 5-digit answer or a 5-block answer. Right? Again, understand the logic with respect to the places. Right? So for 3 cross 3, I divide my answer into 5 blocks. Okay? Same story. This is the unit, 10, 100, 1000, 10,000. That's the 10 power 4 basically. Clear? Now try to write it down yourself while I try to explain it here also. You'll see, you'll figure out the pattern. This is simple CF. Right? From where all will I get the 10 from? 10 into 1. And again this one into this 10. So there are, both of them will give me the tens digit, similar to the previous example that we saw. Right? So I'm writing it down as BF plus CE. Again, these are only for your reference to understand the positions, not to memorize the ABCDs. Clear? Now, from where all will I get the hundreds digit? 100 into unit place. This 100 into this unit place. And this 10 into this 10. Is it clear? So where am I getting the extremes? That is 100 into unit, AB, CD plus BE. Do we understand this? I'll probably write it down again a little clearly, but note this down as BE. I have, sorry, this was AF, so sorry. I have AF, I have CD, I have BE. All the hundreds position we are taking. 100 into 1 is also 100, 10 into 10 is also 100. Right? Now again, this place is my 1000th place. How do I get my 1000? 100 into 10 and this 10 into 100. This crisscross basically. If you see, another way to remember is you can divide it into two blocks. First take this block, do a crisscross, and then take this block and do a crisscross. Right? So here I get AE plus BD. AE 100 into 10, 10 into 100, BD. And finally, tell me what will be the last position. Very easy. What will be my 10,000th position? What numbers, what alphabets do you think will come here? What product? I think it is simple. Let's see quick. What product do you think will come here at this place? Extreme left end. AD. Good. This understood. Again, first time we are writing it down, probably I also scribbled in a little bit, so it all looks a little messy. But once you start solving, you'll see it is not at all that messy. Right? So once again, writing it down clearly. A, B, C, D, E, F. 2, 3, 4, and 5 blocks. Right? This is CF. This is BF plus CE. This is AF plus CD plus BE. This is AE plus BD. And this is AD. Right? Again, simple. CF, BF, EC, crisscross. Then for the hundreds place, you do extreme crisscross. AF, DC or CD and BE. Then you do a crisscross between these two, AE, BD, and then finally an AD. Clear? Can we try out this? Can you guys try out 36 quickly? (197 into 342). Can you guys try out? Like I said, if you want, if it is easier for you to write it this way, go ahead. There's no stopping. So we can quickly write. I'm also writing. I want you guys to solve simultaneously on your own. 7 to 14. 9 into 2, 18. 7 into 4, 28. 28 and 18 is 46. Then I have 2 plus 21, 23 plus 36. 23 and 36, 59. Then I have 4. I hope you guys are getting it. I'm trying to speak out as I do so that you understand. Yes, Kavya, that's correct. 673, 74 has to be your answer. Like I said, filling it up, you get this, and then you adjust, you push. This one will go. So 4. 46 will become 47. 59 will become 63. 3 here, 6 here, 31, and 6 is going to be a 37. 6, 73, 74. Is this clear, everyone? Can you guys quickly try out 37 and 38 also for practice? 37, 38 also. And I think there was one more question in this page. 112 into 43. Now, 112 into 43. Now, so far, I saw two methods. One is a 2 cross 2. One is a 3 cross 3. I don't have any method for a 2 cross 3 and all of those kinds. Hai na? So, what I could do rather, I could treat it as a 112 into 043. And then I can use the 3 cross 3 method. Is that clear? Try out these questions quickly. 35, 37, 38. I'll give you 1.5 minutes. And like I said in the very beginning, all of these methods focus on the speed, focus on the speed. Even if you're getting a little digit here and there incorrect in the beginning initially, that's fine. Quickly start putting up answers. I see in the beginning I was getting a lot of answers. All of you were really hyped up, but I think with too many calculations, you guys have gone a little down. Keep putting up answers. Yes, I'm writing it down here. I'm writing the answer directly. 273 into 349 is 95277. Yes, Kavya, correct. And 769 into 414 is going to be a 6. 30. Clear everyone, 2 cross 2 and 3 cross 3. And again, let me tell you this. If you see so far, when we were doing the crisscross method, when we did the base method, there were a lot of restrictions that we discussed, right? It is good. It is a wonderful method, but it works only in some cases, right? Or rather, for father of numbers, if now 197 into 342, I wouldn't want to do it with the base method. Too much of complications there. This crisscross method is good in a way that it has no restriction. Any question, any 2 cross 2, any 3 cross 3, you should be able to do. And I want you all to practice these two very, very well. Right? You should be able to solve questions using these methods, base method also, and this also very, very quickly. 39 and 40, don't worry. We are not going to do it right now. I want you all to be thorough with a 2 cross 2 and a 3 cross 3 for sure. Right, 4 cross 4 is not I'll just tell you how to do it. Probably we'll just try to figure out a pattern. You see, the pattern will be same like we did for 2 cross 2 from the ones, 10 into 1, 1 into 10, then 10 into 10. Same way for the 3 cross 3, we did 1 into 1, 10 into 1, 1 into 10, 100 into 1, 1 into 100, 10 into 10, like that, how we went. So the pattern will be similar. So we'll just look a little, we'll take a look at that. But don't worry, we'll not get into solving a 4 cross 4 right now. And you also don't have to, I wouldn't really stop you from practicing it, but focus more on the others focus more on the 2 cross 3 and the 3 cross 3. This, if you ask me, 2014 into 2013, wouldn't you want to do it with the base method? Wouldn't base method work faster? Yes, no? Can someone solve this 2014 into 2013 with the base method quickly and tell me the answer? Just because we learned a new method, we can't afford to forget the previous one. Can we quickly do 2014 into 2013 using the base method? So that will be a recap also for you to remember. Agreed, 14 and 13 are not too comfortable numbers, but again, that is not something that is too difficult either. Can someone solve 39 quickly with the base method? Quick, I'll give you a minute. Give me the answer, and please don't use any other method or calculator. That takes away all the fun. Okay, I'm also trying to do it here. You guys also do it on your own, and let's see. So I have a 1, 14 plus 13, 14 into 13. Simple. The only trick here is whether you know 14 into 13 or not. That probably might be a little question that will come to your mind. But if you remember 14 into 13 itself, you can break it up. Either you know it, either you can do it in any shorter way you want, or 14 into 13 itself is a 10 plus 4, 10 plus 3. So again, you can do a 1 a plus b ab there also. 1 a plus b ab, if you do there also, you will get a 182. Right, I need to take care of this m. So I have 182 as it is. 27 into 2, 54, and a 4. So now what is my answer? 4054 182. Now you see, even while we were solving base method and crisscross method and all of that, suddenly when this question pops up, you need to realize this is much easier to do it with the base method, because both of them are close to 2000, rather than doing a crisscross with the 4x4 method. Clear? Now, and don't worry, I mean, the next couple of quick tricks that we'll see that are going to be really, really simple ones to wrap up the session in a simple way. But base method and crisscross method, please go back and try as much as possible. Now, one question for you guys. For a 2x2, okay, we got how many? We got answers in terms of 3 blocks, 3 sections or 3 segments there were. For a 3x3, my answer had 5. Any guesses? A 4x4 will have how many blocks? Any guess, anyone? Can you figure out a trend, a pattern? A 4x4 will have how much? 5x5 will have how much? Although don't worry, we are not going to go there. 4x4, any idea? Sindhuja, yes, 7. A good way to remember, again, like I'm saying, we're only trying to understand this. You may or may not actually go ahead and practice 4x4. I'm only expecting you to do a 2x2 and a 3x3. Be master of it. Be very thorough with it. You have to be, very efficient in those. 4x4 not needed so much. Now, but to remember this, there is a sort of a triangle that you can remember. 1, 1, 2, 1. 1, 2, 3, 2, 1. 1, 2, 3, 4, 3, 2, 1. And so on. It will go. Now, can someone tell me, I'll tell you what is the significance of this triangle to all the crisscross method that we did, but can someone tell me what these numbers are? 1, 121, 1, 2, 3, 2, 1, 1, 2, 3, 4, 3, 2, 1. Do these numbers seem anyway familiar? I'll give a hint. This is 1 square. This is 11 square. Till here we all know. Correct, Kavya. Next. 1, 2, 3, 2, 1. Can someone tell me this is a square of what number? Any idea? Can you pick up a trend? A pattern? Very good. 1, 1, 1 whole square. This is 1, 1, 1, 1 whole square. Right? Again, this is an additional thing you can, probably note down. Good thing. If ever, sometime you have to calculate the square of a number which is of this format, 1, 1, 1, 1, 1, 1, any number of ones. Remember, the easiest way to solve it is there are 4 ones, na? So go write down 1, 2, 3, 4, and then come back 3, 2, 1. As simple as that. So for example, if there is this number 1, 2, 3, 4, 5, 6 whole square, what is that going to be? 1, 2, 3, 4, 5, 6. You go up till 6 and then come back. 5, 4, 3, 2, 1. This is the answer for 1, 1, 1, 1, 1, 1 whole square. Right? Now, let us understand what is this pattern, or what is this trying to tell us about the crisscross method that we learned. This is a 1 cross 1. This I am not really bothered. This is reference to your 2 cross 2 multiplication. This is reference to your 3 cross 3 multiplication. And this is reference to your 4 cross 4, and so on it will go. If you remember, in your 2 cross 2 multiplication, your answer had 3 blocks. Yes or no? And each block had how many calculations? This was simply one calculation, unit into unit. This came from two numbers, if you remember. The middle number, the middle digit came from AD, one calculation, and BC. So two calculations. Again, the last one was a single calculation, AC. So this 1, 2, and 1 also signifies the number of calculations in each block. Right? Now, 3 cross 3, what happened? This was simply a unit into unit. For this, I did a 10 into unit, unit into 10. So two things. For this, what did I do? 100 into 1, 1 into 100, and 10 into 10, meaning it had three components. Same way, this one had 100 into 10, 10 into 100. So again, 2. This one had 1 again, 100 into 100. So that is probably the significance of this triangle to your crisscross method. So once you're back home, probably like I said, just you can give it a try. I don't want you to, spend too much time or practicing too much of 4 cross 4, not necessary. Be very thorough and practice and get efficient with a 2 cross 2 and a 3 cross 3. This is something that you can know. The pattern will continue in the same way. How do you get the units place, tens place, hundreds place, 1,000, 10,000, and so on and so on. Okay, so this is just something to note and remember. And like I said, at the end of the day, when you know multiple methods and a problem is in front of you, you should still be able to decide which is the best way to go for it. Right? And one more thing is, all of these methods that we have discussed and the one more that we're going to discuss also, this is not, like I said in the beginning also, if you're waiting to apply and practice all of this only and directly apply it in your exams, that is not really going to exam. Yes, mock exam you can try, but you ultimately wait till the exam to practice and experiment all of this. It is not going to work out. On a daily basis, try to pick up any number and try to solve. Try to get very, very thorough. Practice as much as possible so that when you do it in an exam, you're confident about it. It shouldn't be the case that you do one of the shortcuts, then you are confused, then you do the normal multiplication to check. You're wasting too much time. And also ensure that you're very, very thorough with these methods and practice as much as possible, because it's not going to come in a day or a week. It needs a lot of practice. Right? Before we wrap up, one very, very easy and the last trick that we're going to look at, probably, I'm sure a lot of you may have, learned the shortcut of 55 into 55 way back in school. But there is a pattern. See if you can figure out a pattern in all the 5 questions, and the answer will come in a matter of seconds, trust me. 2 to 3 seconds, you'll get your answer. Do you see a pattern first of all? And trust me, I'm not using a calculator right now. I don't have the answers written down also anywhere. But these numbers are so easy to calculate. Do you see a pattern? Anyone? Can any of you identify a pattern in the 5 numbers? This is probably the easiest of the methods that we're going to look at today. Okay, Kavya, what pattern do you see? Adding up to 10. Yes. Now, whenever you have the units digit adding up to 10 and the remaining digits being the same. Okay. So something of this type. Let's say I have a number AX and AY. X and Y, that is the units digit, should add up to 10 and A should be the same. The remaining of the number should be the same. So how do you get to solve these is very, very simple. You simply do an X into Y. And remember, that has to be a 2-digit number. So if you get a single digit, you have to push a 0. X into Y, a 2-digit number. And the next one will simply be A into A plus 1. I'm sure, like I said earlier, also a lot of you would have been taught sometime in school. Maybe it looked like a really cool trick to know, how to find the square of any number ending in 5. What is the logic? If you see, square of any number ending in 5, meaning 5 and 5 is 10, and the remaining part is the same because it is a square. So it exactly fits into my AXAY pattern. That is why it is very, very easy for me to find the answer. 5 into 5 always ending in a 25, and the remaining is what? 2 into the next number, 3. So 12. The same pattern is what is being used in every sum here. 49 into 41. 9 into 1 is 9, but like I said, we have to write it as a 2-digit number. So 0, 9. 4 into the next consecutive number, 5. 4 into 5, 20. Again, 1 into 9, 0, 9. 8 into 9, 72. 5 into 5, 25. 10 into 11, 110. 24 into 26, 4 6 are 24. 2 into 3, 12. Right? Can someone quickly tell me? No calculations, nothing. 83 into 87. Under 3 seconds, all of you should be able to give me the answer. I mean, maybe you will not be able to type so fast, but yes, give me the answer quick. 7221. Very good. Probably you see the time that I spent writing down, you know the answer even before that. Right. One more. Let's see. 74, 76. 74 into 76. 56, 24. 74 into 76. So 6 into 4 units digit 24. 7 into 8, 56. Right? Someone tell me 122 into 128. Again, the logic, everything is the same. 122 into 128. Again, units digit are adding up to 10. So 2 into 8, 16. The rest of the number, take it together. This entire thing remaining is 12. So I need to do a 12 into 13. 12 into 13, I hope all of you know it is a 156. So 15616 is my answer. Clear? Okay, so one more, last one of this pattern. Let us see. 37 into 33. Again, very simple. 37, 33. Which makes me realize 45th one I made a mistake. 24 into 26 will be 2 3s are 624, not 1224. Right? So 37, 33 is a 1221. Simple. Clear, everyone? Good. So any doubts, any confusions in any of the methods? Obviously, like I said, the methods are not something that is going to, be very thorough in the, immediately, but it will get thorough the more you practice it. Again, you have a calculator in some of the exams, but like I already said in the beginning, do not depend too much on it. Knowing some of the shortcut tricks, you realize 37 into 33, by the time you take the mouse and punch in all the four numbers and then into and everything, you already have your answer and you move on. So a lot of times that can happen. Use calculators where you really believe that it is a time consuming one and you do not have enough time, but ensure that using the calculator itself doesn't make you waste your time. That shouldn't be the case. Okay, so quickly summing up all that we did today so that you can go back and practice all of this very, very well and very thoroughly and very regularly. One, we did the simple base method with 10 power n thing. Then we did another variation of the base method with m into 10 power n thing. Then we used the base method for squaring. We did base method for cubes. Then we did crisscross for a 2 cross 2. We did crisscross for a 3 cross 3 and an extra additional, the last method that we looked at. Right? So we have clearly 6 to 7 different methods, and in between also we just discussed about a few tips and tricks using a plus b whole square, a minus b whole square kind of a thing. So ensure you go back and practice it thoroughly. Right? One more thing with respect to your books, I hope all of you have had a chance to take a look at your books. Remember, after every chapter you have something called a practice exercise that is meant for your practice. So ensure you go back and solve those questions. Then there is a class exercise which we are obviously solving in the class, and even within the class exercise, if there are questions, today it was speed math, so we did all the questions. But you'll go ahead and see in your exercise there are some extra practice questions also given in the same class exercise, so go back and solve them. And for further classes also, remember, from the class exercise also, it may not always be possible for us to solve all questions from the worksheet in each class, so those are also supposed to be done later by you for homework, right? So the extra practice worksheet as well as the questions that are left out from the class worksheet, you are supposed to go back and try it out on your own, and you can always put back your doubts on the discussion board, or we can discuss it in the next class directly. Right? If the next class is a few days later, ensure you don't wait too long for that. You can put it up on the discussion board. We can discuss it in the class also. Clear? So anyone, any doubts, please feel free to ask. I'm here for a few more minutes before we wrap up. I hope you followed the different methods, techniques, but as I've been mentioning and repeating over and over again, you will be thorough with it only and only when you try them out. Right? So, any doubts, confusions, questions? I think we are a little ahead of your time already. So, yeah, let me know. Okay, if there are no doubts, you can say no doubts. That is also fine. Fine. Okay, so that's all from my side, guys. Thank you. Have a nice evening ahead. I'll see you all on Friday again. Okay, Farhan, you have a problem with the cubing method? Okay. Cubing, like I said, very, very similar to the base method, very similar to the squaring part actually. But since we are multiplying three numbers, whatever other numbers we did, whether it was 2-digit or 3-digit or 4-digit, but ultimately every question we have been multiplying only two numbers. Whereas cubing is one thing where we are multiplying three numbers. Right? That is why the technique, the method here is slightly different. Right? You start off with the same way, m into 10 power n plus a, plus a, plus a, plus a. All the three numbers are going to be the same, like we did a 9 here. The only thing is you need to remember this one step. Right? For everything else, it is 1a plus b ab. For this, it is slightly different. So this is something that you need to remember for cubing. 1, 3a, 3a square, a cube. If you need a shortcut to remember this, you can remember it as a 1 plus a whole cube. 1 plus a whole cube will be what? A cube plus 3a square b plus 3ab square plus b cube. So basically that formula is getting applied here. If that is confusing, if you can remember it as it is, 1, 3a, 3a square, a cube, that is also fine. Whichever way you choose to remember. And the adjustment with the m is also exactly the same. I need to start multiplying from the rightmost digit, and I need to start multiplying from m power 0. Empire 0, Empire 1, Empire 2. Since there are 4 blocks, so far we are having only 3 blocks earlier, so I did only till Empire 2. Since here in a cube I have 4 blocks, I need to also take care of Empire 3. Right? And then everything else remains the same. Like we also had written down the example of 109 whole cube. 109 whole cube, how will I write it? 10 square plus 9. No? So my A is nothing but a 9 here. So 1, 3A, that is 3 into 9, 27. 3 into A square. A square is 9 square, 81 into 3. 81 into 3 is 243. And then I have to do an A cube, that is 9 cube, 729. This was a 10 square. So how many digits can each block have? It can have only 2. So the 7 should move out. I'm left with 29. 243 plus 7 is nothing but 250. But I can only retain the 50. The 2 has to move out. 27 plus 2 is 29 and I'm left with 1. Right? Quick question here would have been, if I was cubing 1009, if I was doing 1009 whole cube, this first step would have been the same for me. Just that instead of 10 square, I would have written 10 cube plus 9 and this first step would have been the same. In that case, what would my answer have been? Since it is a cube, I have to give 3 digits everywhere. So 729 as it is, fine. 243 as it is, fine. 27 I should have forced a 0 to make it 027 and then a 1. Obviously, you see how big that number is because it is 1009, a 4-digit number ka cube we are doing. This is that bigger number. But when you're doing 109, you have to adjust. You have to ensure that every block has only 2 digits. Is this clear? Again, like I said, even within the base method, like in the crisscross, I said, get very thorough with 2 cross 2 and 3 cross 3. 4 cross 4 can wait. You need not worry too much about it. Cubing is not so, you cannot neglect cubing so much, but focus on the normal base method and squaring first. Get very thorough with it and then start practicing the cubing. Okay? And once you solve a few questions, I'm sure it will get a little easier. If there are still doubts, we can probably discuss in the next class. Okay? So that's all from my side, guys. Thank you. Have a nice day ahead. Bye.